This video introduces us to the concepts of Chapter 2.3. It's a short lecture, covers a few of the different types of graphs that we look at and you should be familiar with. Let me show you that, and I'll fill in some of these blanks. I have your note sheets ready to go, but let me show you the PowerPoint just to talk you through a couple of things. And so the first type of graph we look at is going to be called the frequency polygon, but we introduce another term for you. In the previous section, we introduced you to the lower class limit, upper class limit, and so we're going to be using this idea in the class midpoint. So we just define that for you right now. It's the middle of where the classes are, and we'll talk about it. So, for example, we have a lower class limit, upper class limits, and then the midpoint would be somewhere in between. We end up using that, and you can see an example here of what the midpoint is here, 675, 685. It's the value right in front, and that gets kind of utilized with the frequency polygon. It's just a graph that uses points, and so let's, for example, look at some information about the time in between eruptions at I think this has to do with if you've ever been to a national park, the national park with the hot water geysers that go off, they put water up in the air. They measure how long in between each of those eruptions and how frequent that happens. And so that's what it's looking at here. What we're looking at here. And this is what the graph would then look like. You can see it kind of looks like a polygon. That's why they call it a frequency polygon. It looks like a polygon, and you just can track how often it happens at these times. And notice the midpoints of the classes are being used with the frequency or the relative frequency, which we learned in a previous topic, right? And so that's all we have there. And so if you were going to fill in any information on your notes, again, all we're looking at here that you would want to make sure you get, again, this here is a frequency polygon. The word's already there, but you can fill it in. A frequency polygon, right? It's a graph that uses points, uses the midpoints, and then you graph the frequency or relative frequency with those. And so we have that. We then take that to another type of distribution or display that we look at. So you've seen this before, frequency, relative frequency. What we added over here is a new term, cumulative frequency and cumulative relative frequency. And so that's what we're looking at here. And so those terms are related to, if you can see, like, take a peek at where those numbers come from. Think about, see where they, how we're generating them real fast. If you look carefully here, you'll see 2 comes from 2 here. And then these are kind of what we call running totals. I would say, that's another word that I would use. You may have heard that term, running totals. You're keeping track of the total amount as you keep adding. So for example here, you have 2 to begin with, and then you get no more, so your cumulative, your total amount, right, your aggregate is 2, and then you get 7 more, and now your total is 9. You get 9 more, now it's 18. You get 9 more, now your total amount you have is 27. It's like a running total. 11 is 38, 7 is 45. And so then you have that here. You can see these are your percentages, right? This, that right here, this number here comes out of 2 divided by 45, and that equals 0.0444. That's where you're getting those. Again, those out of like percentages, 2 out of the total amount, which is 45. An important characteristic here is that when you add this up, the sum has to equal 1 because it's the 100%. This is the relative frequency. This gives you the total amount of 45. And so looking at this example real fast, we want to create a cumulative and relative cumulative frequency table for this. And so that's what we'll do. Think about how we would do that. I'm going to create it, and then it'll pop up on the screen right now. And so if we wanted to make a cumulative frequency table here, you would say, how much do we have in total at the beginning? You have 16, and then I get 3 more, and so then that would be 29. I get 4 more, and so that would be 33. So we end up with 33, and then you get one more, and 34, get 0, so you still, your total amount is 34, get one more, so now you have 35, get 0 more, so your running total is 35, get 2 more, 37, 2 more, 39, 1 more, and 40. So you can see 40 is the total amount. And if you're going to do the relative cumulative frequency, you just do 16 divided by 40. This would be 29 divided by 40. This would be here 33 divided by 40, and so on. And then you would put your decimal approximations for that. And then you would get down to the very bottom, and this total would be 40 out of 40, which equals 1. So you end up with your decimal values here. And so then you would see, I'm not going to do the whole values, keep dividing, but you can see 40% and then 72.5%, 82.5%, and you continue dividing this by 40 until you get all the way down till 1. Here, that'd be the total relative cumulative frequency, because that represents 100. That represents 100%, and so forth. And then the last graph we introduce you to in 2.3 is called a time series graph. And so that's actually something you're probably very familiar with. Here is a time series graph right here. Let's see if I find, there's a lot of different graphs. We're not going to do them all. A time series plot, or time series data, right, is obtained by plotting the time in which a variable is measured on the horizontal. So that's your time, and then the corresponding value on the vertical axis. And so here's your idea that here's your time, here's your value, and when you graph it, you can measure the progress over time. And so that's what you would be putting into here. If the value of variables measured at different points in time, the data referred to as. And so again, you would come back to over here. It was referred to as time series data would go in there. And the other one is a time series plot. And so you would put that in there, referred to as time series data. Time series data, right? Your x values are time, and then a time series plot or graph would go here. Time series plot or graph is obtained by plotting that and then connecting them. That's chapter 2.4.